This is a detailed version of how to create P chart using Excel, and we are going to compare the result using many tab software also as well. So this is what you can get it. You can get the control limit. When you say control chart is all about control limits, right? You will get that one, and then you will also will learn how to calculate what's the formula and so on. In the past video, we talked about the U chart. The U chart has a formula called U bar plus 3 root of square root of U bar divided by N. But the P chart has a different formula. Same thing, P bar plus 3 square root of P bar 1 minus P bar divided by N bar. Meaning, whatever the sample you take, that you need to take an average. Let's set the context first. Let me take brand new Excel. So what we are talking about is that, let's say, defective. Anything fully is not usable is defective, right? So in defective, let's say you have two defective, and out of you have tested volume of, let's say, in this example we say bulb, right? So how many bulb been tested? 100. That means how much defect we are talking about? 2%. 2 divided by 100. The same concept, P chart works, right? P gives that how much proportion, for example 2%, 3%, then how much percentage, and then we can have that control limit. That's what it is called, control chart. So now what I'm going to do it is that I'm going to have this header and create the own examples, and then we can take a look. Let's say sample, let's say I'm keeping the sample of 500. 20 samples been taken, or it is been done in 20 days, example, let's assume that. And defective, so in defective what I'm going to do is that I'm going to say random between 1 to 10, example. I'm just dragging it up, and if and this will change every time. So what I will do, I will just copy and paste as value. So now this will not change, right? And then P bar. So same simple formula, defect by volume. For example, here in this case, very small percentage, right? And 0.6 percentage, less than 1%, and drag it up. And now here, what I can do is that I can take the average confidently, 0.9 percentage, it should show up. And generally speaking, when you have a different sample, if the denominator are different, then average is not a good method. So what I'm doing it, you can just do this method, like sample of everything, sorry, sample of defect divided by sample of how much sample you are going to test it. So this is going, it shows that it is 18. So something wrong. Wait, let's see. So now we are talking about 0.91, and there is something wrong here. So I have not given some formula here. So just giving open parenthesis, I will close the parenthesis, and now it should match exactly like zero point 0.9, right? So now this has been done. Okay? Technically, what we are saying is that sum of this, right, 20 divided by this value where we are talking about, right? 0.9 percentage we got, but here we can verify this value. Okay? The formula part is in very interesting one, right? This is a formula. You see, I will just keep it in the bigger screen so that it is visible. So P bar, this is our P bar, right? Individual P bar value. This is your individual value. This is a P bar. Bar mean average, like P bar, U bar, X bar, R chart, and so on. An LCL, so we can take this plus, I'll start introducing bracket, 3 into square root of 1 minus square root, again I'm gonna go with this one, d2, divided by n. N I will keep it here. I have not determined the n yet. I'll keep it here. give okay. Sorry. Okay, give okay. And here n you can see here. So this is n has n bar, right? So n bar is nothing but average. So here average of 500 is, of course, 500 is an average, right? So now we got this percentage, right? So now G2 and D2 is going to be dynamic. So I mean it's constant. So I'm gonna give absolute reference by pressing F4. So now it has been done. So I will drag this up. So this has been ready. So I will convert back to percentage and just control percentage P, you can just control. So now 1.5 percentage is our upper control limit. The same thing we can do here. The only thing is that we're gonna apply minus because the same formula, ditto same formula, only thing we are going to apply minus. So here 0.3 percentage is fine. If supposingly if you're getting it in the previous example, the actual value we are getting it is, let's say I'm just removing it if condition here. So it is 0, right? So in this case, this is fine, right? Even if you're getting the minus value, you need to convert back to positive value as it. That's one of the small thumb rule as it, right? So now we've got this value. Now we don't need this formula. We can delete. Okay. Now what I'm going to do it, I'm going to drop the control chart. So the third one, so just give here. Okay, I'll give a title. The chart for land defectives or scrap or whatever. And now the interesting part is that I don't need the grid lines, and this is in all the same value, right? So now what I will do, I will just click on the last cell. I will just give here, and then I will just click here. I will just call out this value actually. Or you can either you can drag this up using that mouse, or you can just, maybe I'll show you this one, or you can just right click format and then you can below or above or whatever you can do. So anything which works best for you. So it's now what I'm doing it, I'm just all these value, I'll just call out a bit with the bigger font, 3 or 12 example, and this one is 12 again. This one will keep it. Yeah. So now, sorry. Now you see that this also we have done. Now let's compare that value here, right? So maybe one thing I will do it is that I will, this color I will change it, because in rejection we say green, higher the percentage is not good, right? So I'm going to keep it red. Here I will give blue, and here I will keep it the same color as it. So now this is the one, and then I can also see here. So now you see that so there are outliers. I mean, when it comes to rejection, outlier should not be on the upper side, whereas the lower side it can be there, right? So no problem. But upper side it is, and there are outliers, right? So let's see the same result using Excel. Whether Excel gives the same result or not, we can find out. So what I'm doing it, I'm just taking new, I'm going to menu tab, MINITAB. I'm going to open menu tab and paste it here. Now you see that I don't need all of these value, right? So okay, go back, I'll just copy this value because menu tab will calculate everything. Go to stat, go to post control chart, and go to attribute chart and P chart. Right? And so this is defective lamp divided by sample size. This is great. Now how much you are getting it? 0.91, exactly the same value. 1. Now here we are getting a different value, right? So let's see 2.1. Is the value being pasted properly? The last value is 6, yes. And let's see why it is not taking that value. I think there is something wrong with the formula. So it says 0 and then 2.1. So let's go back and check the formula again. So this we are talking about defect and divided by this one. This is correct. And then LCL. So the formula was, let's take that formula again. This is also good experience, learning experience, right? So P bar, that is 0.91, that is D, plus 3 into, okay, so 3 into, it is taking this as a, okay, 3 square root of 1. Oh, P bar we are missing it. P bar we are missing it. Okay, so, okay, and D2 1 minus, okay, so here we need to keep it bracket. We have applied the, we have missed P bar here. I think that could be probable reason. And good that we have discovered that. Okay, okay, 2.2 percentage. And what I'm gonna do is that D, we need it as an absolute reference. I will give a 4. Enter here 2.2 percentage. Click here, and the same formula I will copy and paste it here. The only thing is that I'm gonna give minus here. Okay, this is exactly what I was saying. The the rejection cannot be minus. So what I will do, I have to give one more instruction. If this value found to be minus 0, right, then return as plus 0, right, just 0. Okay, and just dragging it up. Now, okay, so let's go back. So sorry, we missed that P bar. So one more time, we'll go through the formula. This is the formula. So P bar, 3 times P is coming on the numerator. In denominator, there is no P. So P bar plus 3 square root of P bar, 1 minus P bar divided by N bar. So now we'll compare this result. So 2.18, 2.184. Let's see whether we are getting 2.184. Let's, exactly, we are getting the same. And 9.1 we have got, and then we have got 0. Exactly the same value we have got, right? Very, very same value we have got. And you can see this is how we can create this one. So what is the beauty is that even if I do that changes here, let's say I'm just making it 1000. So the graph will get updated automatically. You can see the graph has been updated even in many tab. So what I will do, I will make it 1000, and I will just go to graph, or I can just copy all this value, go back to graph, just right click, update graph automatically. Now it is updated 1%, 0.4 percentage, not that, exactly the same value we have got, exactly the same value. So now even if I change this value, right, so I'm just giving random between, and just taking it like 1 to 12 example. Slightly the rejection is up 1 point. Let's say I'm just copying this value because I need to test this value using Minitab. Okay, copy this value. So now we are getting 1.522, right? Let's see whether we are getting 1.522. Paste this value here. Copy this one. Paste it here. And go back to this graph. So now 1.5, exactly the same value, right? Now, one thing we are going to do is that we are going to vary the sample size, right? Completely, we are going to change it. Now that will be tricky, right? In Excel, Excel may not give that accurate value. Sometimes it gives, sometimes most of the time it does not give that accurate value. So let's say my sample every time differs between, let's say 500 to 1000 pieces I take, example, bulk, or my incoming received quantity varies every time. So let's see whether it gives the same value or not, right? So now the average value is 765. Let's say whether we are getting it. So now copy this value, go back here, paste it back here, go back to graph, and then we are getting 1.923, 1.989, not this one. There is a subtle small changes is there. So that's what actually when you do that actual value, like for example, even if I do that, interchangeably, if I do like all the time I'm just saying 500, then I think Excel and will work and it gives the right value, right? For example, 500 across the board, I'm pasting it, and if I test it, it should be the right value. But when you have variable samples, so Excel sometimes does not give the right result. For example, let's say the 3 percentage to 1.4 percentage, right? So it has given. So if I vary it, let's take one more time whether the result is going to be same or not, right? 500 to 1000, right? Just dragging it, copying this value and pasting it here. Again, one more time, copy this value, paste back in mini tab. Just go to graph and see 2.2, 2.01. This is not matching. This is not matching, right? So when you have too much variations in the your sample is variable samples you have, right? Then it's not better, not you don't do it. Although you have that formula called n bar, but or even if you take maximum, right? Even if you take maximum, sometimes it works, but most of the time it does not work. But many tab always gives you the exact right answer, right? Example, and this again the value value hasn't changed. That's a good thing. Okay, so what I will do, I will copy, paste it here, take this value and go back to mini tab, paste it back, come here and see 2.27. 2.27. No, it's not matching. Not matching, right? Even if you take average, 2.1, right? But here the actual result, Minitab gives very, very accurate and perfect result, and this is not matching. So whenever the only in Excel, when you have, you can frankly and boldly use when you have confidently you can use when you have a sample size almost a constant, you can use it. It will give the same result. Like the example, I'm just testing it here. It should give the same result 1.522. Let's say I'm just taking it here. I'm just copying again, pasting it here. So now going back, it is exactly it is giving the same one. The only this is the only lesson we have in many tab, Excel actually, but in many tab, it doesn't require any calculation. It gives straight away the results, everything. I hope you find it useful. Of course, you can very well do that formatting furthermore, and you will have fine tuning and all that. So dynamically, whenever the changes is there, for example, let's say you can also highlight it. Let's say this cell is going to be changeable. So you can just highlight it so that and all these will automatically calculated. It's a one-time thing. So once it has been done, so your values will get automatically get updated. I hope you find it useful. Thank you so much. Now let's take a look on NP chart. NP stand for non-conformity proportion or non-conformity product or services whenever you have in any NC part. N NP chart can be very useful. An NP chart comes from the family called attribute data. Attribute or discrete data, the data which you can count or classify. Since the very nature of attribute data is to classify, right? Hence, in the family of defective, you can use P chart that we saw before. Now we are going to take P stand for proportion. Now we are going to take a look on NP chart. So NP chart required just like anything P chart, it requires only defective as well as how much sample been inspected. Using these two columns, we can easily calculate the rest of other columns. So all the one which are there in the black font are the calculated one. So let's discuss about, now we talked about uh, the the data type. For example, it comes in attribute data and all that we talked about. Now let's take a look on what's the formula. Formula for the NP chart is that, for example, in order to calculate, let's start with the P bar, for example, the NP bar. So NP bar, if you wanted to find out the NP bar is nothing but same like what you usually do for the P bar. What do you have to do with the P bar? So, for example, P bar where you will take the sum of defective divided by how much sum of inspected, right? So this is what you will do it. And now in one more thing, what you will do in this NP chart is that converting from P bar, that is proportion to this one, NP bar, of course, it is there in the percentage. So submissive of again, so what is the one? So defective part. And instead of inspection, what you will do, you will go with N number, right? For example, here we have 25 is the sample. That 25 you will get. With that, NP bar, as I said, that bar is nothing but average. So you can easily find it out. So this is the difference between P bar and NP bar. Remember, P bar goes with the defective and versus in inspection quantity, and NP bar effective versus the number. It doesn't calculate on the one, although it's in the subsequently for LCL, we're going to use both of these components. Let's take a look. So what is the formula is that, let me take new sheet. So as I said that NP bar and P bar. P bar we have learned it's summation of defect divided by summation of inspection quantity, right? With that, we can easily find out. P bar, summation of defective. So this is also defective, not defect, divided by, and you need to put N, how much samples or how much subgroups you have, right? So this is the way we can easily calculate. Now we are talking about the LCL and UCL. So L, lower control limit, upper control limit. Lower control limit is that formula is very, very simple. NP bar, that is the value what you are going to get it, minus, since we are talking about lower, so we need to apply minus. And then you have 3 into square root of, you have two component, NP bar, and then 1 minus of P bar, right? 1 minus P, what will happen? For example, you have now you will get like a yield percentage, right? For example, your percentage of defective is 10 and 1 minus P is 90. That's what easily you can easily identify the formula. Now with that, we can easily identify UCL. That is, all we need to do is that you need to make it plus. This minus will become plus. So this and NP bar, once again, square root of NP bar, 1 minus P bar as such. So this is the formula. let's apply that formula and get this value, right? As I mentioned that let's do it from the scratch. We do need two components. One, we need inspected quantity and do need the defective number of defective quantity. And if you wanted to use, let's say you wanted to use something called month or date or whatever, maybe you can use it. Maybe I'll make it very simple for you. What I will do, I'll make only Feb to December, only 12 data set I have. And then let's say the quantity of inspected quantity is 500 example. And I'm just giving across the board. Let me keep it as a fixed sample. And then defective. So defective, let me keep that each time the defective rate is going to be 10 between 20 example. Or yeah, so now we got this one. For example, the month of Jan, we got 20. This is normally what you will say. This is what you will do it in the bar chart, right? So bar chart doesn't give you a picture that how much samples, how much errors are happening and all that. It gives that idea that how much error is happening, but what's the lower control and upper control? That's what we are using control chart, right? So let's find out one by one. So with these three things, this is your input, and we can make it to only this is okay. And then with that we can put like p bar. I have this heading, so I can copy paste this one. Okay, now with that we can easily identify this. So how we can do, for example, p bar. P bar, as you know, that formula as I mentioned, sum of defective divided by sum of inspected. Right. Now the whole formula I'm going to repeat again because I need to add that up. So I will give you a 4. Okay, okay, okay. I applied a 4. So now, for example, in this case, January, we had 2.6 percentage defective, and it goes on, right? I mean, this is an average, right? We are not talking about individual percentage, but sorry, we are not talking about individual percentage. We are talking about overall. Well, this is we got the center line, and then NP. NP, how it goes is it requires N, right? So N we already know, but I will invoke the formula. So let's say minus 1. So 12-month data we have. So because 1 is for heading, so 12 months. With that, we can easily identify that formula. Sum of defective divided by En. And once again, this formula is going to be absolute reference. So I will give a 4. Okay, now this has been done. So 13 NP bar is 13. And so what I'm doing it, I'm just also creating this also as well, so that I can easily copy paste this value. Now this is done. Okay. And the next step, I don't need this much decimal, so I will keep it only 2 decimal. That's fine. Okay. So now that is done. So the other one is that UCL. So now we are talking about UCL, right? So defective and plus 3 into square root of and that is NP. Sorry, need to use NP. So wait, let's do it. NP. This is NP plus 3 in square root of, and in the square root of what we are doing it again, we are doing it NP minus, this is important step, 1 minus P bar. Okay, now we are done, and then close this bracket up, right? And what we can do, we can go back, check the formula again. So formula is pretty much same, 3 into square root, and 2 times we are doing it with NP, and 1 is P bar. exactly 2 time with this NP bar and D is that P bar. So this value is going to be dynamic. So what I'm doing it, F4 I'm giving it. Okay, I'm just creating this. So the same formula, what I will do, I will just apply minus here. Okay, let's do it. So minus. This is now you notice that something important. Now we got 3.8. That means we are gonna leave it. If at all, if we get any minus value, then you need to assume that as zero. For example, here in this case, if you look at it, here we have got zero value, right? So now, for example, let me do it this step for you. If let's forget about this. So NP bar plus this is minus 3 times square root of again this one minus p bar, right? Now this is now how much value you are getting it, you are getting it minus. So the defective will never be minus. So what we can apply is that we can apply if condition here. If this value is found to be minus value, like maybe minus 0 example, or it could be any number, just convert back or to convert back to 0. Assume that as 0, right? So since this value has minus, right, the original value, if you see here, minus value, so I'm just converting back. So now what I'm doing it, I'm this entire formula, I'm giving it F4, and then now it has become this one. So now you got that 0 also as well. Exactly, but here in this case, in our example, the value is not 0, so therefore we will keep it as it is, right? And now this is done. Once it is done, what we need, this is the main component, defective, right? The like individual, and then we need NP, and then we need so this one. So to draw that, to draw the control chart, we need individual defective, as of course, and then we do need the NP bar, and of course we do need the P bar, and then LCL, and then UCL we need. Right? There are two ways, right? Here, I'll every time it will keep it will be changing, so I will just keep it as a value here now. Okay. So now what I'm doing it, I wanted to figure out using the control chart. I wanted to figure out how many are outlier and all that, right? So this is what I wanted to figure out, right? And so what I will do, I will just keep instead of this name, I'll keep this name example, right? So okay, I wanted to add same data. I wanted to add this subgroup, right? All you can do is that you can just simply click on edit, this one, and then add this data, and I will call it as maybe LCL example. LCL has this data example, enter it. So the LCL is ready now, right? Similarly, you wanted to find out UCL, right? Example, UCL you can give here, and then the UCL value you can give it here, and then UCL is also calculated. That means well within the limit, right? And then one more line we need that is called P bar. So what we can do, we can just apply NP, and we'll just keep it like short NP bar. I will manually type it, and then you can apply this as such. So this is like a middle line for us. Middle line is also done. So now symbolically, so anything upper is a more rejection, right? So we don't want that. What I will do, I will just change it back this to other color. So what I will do, I will outline it to red example. And and then here I will use same like how many tab MINITAB many tab using it. Similarly, I will keep it this one, like blue, blue color. Blue color is done, and then let's keep that, the lower is better, right? And when it comes to rejection, lower is better. So I will use light green example. It's too much light. Okay, let's say I will use this one, right? And then what I will do, I will just invoke this from invoke this value. So now the value is been there. Okay. And what I will do, I will just give control B. So the value is well visible and all that, right? And if I just add the entire data levels, it looks very clumsy, right? So what I will do, I will pick up this line and add only the data level for this. Remember, I wanted to reduce this also as well. I'll keep it only two decimal is fine. Sorry, not decreasing the decimal point to only two. This is done. And here also the last data point I will keep it. And this is done. So this should not be confusion. So I will just use down, down I will use it. So it will not be any confusion. Okay, NP bar is also done. The last one is that UCL. So here UCL is also done. Now what I will do, I will just, this color I will give it. Example, I'm just giving this color. And the same color I will give it here so that it is visible. Here also the same color. And here also the same color. I wanted to stand out this number. So what I will do, I will just increase a bit. This one increase a bit. This one increase a bit. This is one way to do it, right? So where we just added a simple chart and then we added all the control limits. This is one way. Another one is that if you want directly like this, what you can do, you can just do like this also, right? And I've selected only for one, and then you can start doing it this way also as well, right? So it has given, and then you can add that individual percentage, and this also we can do, but only missing part here is that the individual one, right? So what you can do, right click, add the defective one, right? So defective, let's go back and edit it. Value is going to be this value, right? We can do that. So any one value we can do that. So whichever works for you can make use of it. Now, very importantly, it shows that NP bar is equal to 15.5, and this is the value. And now by looking at the control chart, all will within the limit, right? And we wanted to determine whether the same value NP bar, so-called the mini tab, MINITAB, is giving the same value. So what I will do, for many tab, it requires only this. All these will auto calculated. I'm just going to many tab in here. I'll keep the value here, right? And then start. Then of course, this is control chart, and then attribute chart, and then you have NP chart. So NP chart now defective divided by the inspected quantity. Right? Okay. So let's see. Let's compare that value. So 15.5 exactly the same, and 27.13 we are getting it 26.94. This could be because there is small difference will be there, and here 3.87, closer to 4, and here also we are getting it 4 assets, right? So this how we can easily get to know. For example, let's say if you want, instead of this, if you want month, you can stamp that month also as well, right? Say month you want, you can do that month also as well, right? So this how you can easily calculate this value. And now the formula one more time, let's recap that formula. I'll keep it here. This is the formula, and NP, we're getting the same, and this is NP. NP for us is E, right? Again, once again, 3 into square root of this value, and again you have done the square root of E, again 1 minus P bar. P bar is nothing but for us D, right? So P bar is nothing but individual percentage, right? So individual percentage defect divided by inspected quantity, right? That also we got it. And with that, and then let's try to apply, and so just to ensure that we are doing right thing. 26, actually it is same, right? So this how we can easily calculate and perform in Excel assets. So more value if you add it, for example, automatically it will get added, or even if you change this value, the key is that defective, sorry, equal to defect, random between, let's say I'm just keeping it this. So every time any change, automatically limits get calculated. You don't need to do anything. It's a one-time thing. You set it up and you will get it easily, right? So I hope you find it useful. Please do like, share, them, subscribe my channel. You have wonderful day. How to create C chart using Excel. C stand for count chart. To do the count chart or any control chart, and control chart carry the formulae, and based on that the control limit get calculated. An example, if you look at the C chart, we are talking about LCL and UCL, and LCL and UCL and all these get calculated using the specific formula, right? And this is not given by us, and unlike you have in process capability, you have the USL and LSL where these are given by us, right? This is the specification given by us. But when it comes to control chart carry the control limit. This is auto calculated using the formula, right? Let's discuss about the formula. Formula for C chart is a very easy. And if you say that lower control limit, which is equal to C bar. What is C bar? C bar, for example, you have 1, 2, 3 is a number. And what is a C bar? C bar is nothing but average. Say 1 plus 2, 3, 3 plus 3, 6. 6 divided by 3 is 2, right? So this we call it as C bar. And then minus. So we are talking about lower, so minus should come. 3 times square root of C bar again. This is a formula. And the same thing you have upper control limit equal to C bar plus, all you will be doing it is here minus here plus 3 into the same formula continues, right? And how to create this one, and either using this value, you can also determine in any software, for example, Minitab, MINITAB, right? Minitab or any statistical software, you will be end up getting the same number, right? Let's start from here, right? From scratch. So now here I have given that quantity as a number. Each time the quantity I give differently, and you can see that automatically gets calculated, right? Now we'll do from the beginning and we'll see how we can apply it. Even for volume, let's say you have some volume I wanted to get calculated, you can definitely do that, right? So maybe I will give that here, YouTube, and I will just delete this one. Let's create from the beginning, and also I'll delete everything. Let's do it from the beginning. Let's say this is the 20 data set I have, and this I have a reference. Even this also I will delete, so I don't have anything. So maybe I will call it as A dot one, or I will call it as Jan example. Okay, so different year and month we have. Let's say this is the month-wise distribution we have. Let's say volume I have. Volume this time I'm gonna keep it. We can keep it for defect, but here I'm going to take it for volume. Let's say I'm getting the orders between 1,000 to 2,000 example. And for example, Jan I have got 1,385 volume. This is my volume. What is C bar? As I said, that's average. For now, what I will do, I will just keep this as a value. Otherwise, dynamically, it will be changing. So I will keep it as a value. Now, again, I will apply the same thing because I do need this limit. And then now we are talking about upper control limit. Right? So upper control limit is this one plus 3 into square root of, again, I kept it in the same C2 I will give. So this is the upper control, right? So here C2 is absolute reference for us. So it's going to repeat every time. So I will give F4. and drag it up. So now we got this value. Now what I will do, the only thing is that I need the lower control, so I will use minus. So this is the value. Now what we got, or we got everything. We got the C bar and we got the UCL and LCL and everything. So copy, take this up, go to insert, recommended chart. In the recommended chart, you have this one, right? You can take this up. Let's say you want the chart to be looks good, right? So we'll start, we know that minimum value we have as 1000, minimum 1400, and I will give 1400, and the value maximum it goes, let's say 2000 example, right? So, okay. And then we can start doing from the scratch. Okay, so now we got this value. One more time, let's do it. So this is the average value, and this is lower control, and this is upper control, and this is lower control. Yes, correct. Okay, and I'll just take care this later because I just noticed that we have 1200, 1200 as a limit. So therefore, last time I given 1400, so that's the reason it's not giving it. So now safe side, what I will do is that I will give 1000 as a value example, 1000 to 2000, and this is the value we got, right? So again, I'm just doing a little bit of formatting, and I will keep this as a heading. This is the heading, but this one, this time we are only going with the volume, and we will call it as month wise. And I'll just bold this up or slightly increase a bit. Okay, now we got this value, and all I'm doing it is that this is the initial value, right? So for initial value, of course, I do need the marking. So I'll just right click, add the data label. So this is done. And then the last part is that this limit, for example, if you just click here, right click, add data labels, and here right click and add data labels. Similarly, you do for lower control. So this may be confusing. So I'll delete and I'll look for the last one. And I'll add the data labels. So now the data labels also been added. So I wanted to clearly call out because this value, I mean, initial value and this limit value might get confused. So what I will do, I will just give slightly bigger font, and also I will give this kind of color, right? So it is clearly visible as well, right? Okay. And similarly, I will do that. And similarly, I will do this. So it is fair to say that the volume, the average volume per month we have 1400, and the volume, the maximum we are getting it, the upper is 1500. There are outlier, but actually volume, these are all these big volumes we have. And you can apply, since we have taken a volume, you can apply for defect or any other pattern data set also do that, right? We can apply it. So now what is very, very important factor is that I wanted to determine this value. I'm going to compare in Minitab, MINITAB, Minitab statistical software, right? So because Minitab gives at least 2 digits, so I will just keep it 2 digit here. And let's see whether we are getting the same value. For Minitab, we just need only one column, but I'm taking along with the reference column. I'll just keep it here. Okay, just so this is just attribute data, so no data. Normally data is nothing is required, so we can straight away going for control chart and then C chart. Just click here, and you can see that the value is 1406.2, and let's see how much we got, and exactly the same, and 151874, 1518, and then 1293.7, right? Exactly the same value we have got it, right? but I wanted to keep it simple, right? So I will keep it like this. And further, if you wanted to do that one, but especially I wanted to call out this one, right? So this is very important. And what is the lower control limit, upper control limit, and C bar, what's an average, right? And even if I change this value, let's say I'm just changing it to 1000 to 2000. Let's check one more time whether we are getting the same value or not, right? Okay, now based on this value, the limits have calculated, and let me freeze this up, and then let's go and check that out. Copy this value and go back to here and paste this value here. Come back to, okay, 1 second. We have taken only value, correct. So, okay, come back to graph, and then in graph you have update graph automatically. 1580, we are getting 1580, exactly the same. 1465, we are getting the same. 1350, 1350, right? And anytime when you change it, and automatically the graph value get changed, and you'll have that the entire control chart, properly C chart will be available. I hope you find it useful. Please do like, share, subscribe. You have a wonderful day. We are going to create U chart using Excel. U chart stands for defect per unit. Whenever you have a defect category type, you can use U chart or C chart. C for count and U for defect per unit. And here what we are going to do it is that we are going to create one complete sample under 10 minutes. You will be amazed that exactly how Minitab offers the solution. Exactly, you can do it in Excel also as well. The only thing is that you have to remember this formula. Using this formula, you can create similar U chart as such. When I say similar chart, you can create the same result as such. For example, let's say now, if you look at here, 7.64 is the lower control limit, and exactly Excel we got the same thing, right? And Minitab says that 12.35 is the average, so exactly the same. And then similarly 17 percentage we have got their upper control limit, right? So we got the same value also as well, right? Now what we are going to do it is that from the scratch we are going to develop this one, and so that you'll get an idea that how the calculations happening, and mainly how to create this line, 3 line horizontal chart, right? And also some of the key important aspect to consider, that also as we go along, we can discuss that also as well, right? Let's get going. So this is the dummy template I have, where only when you say defect per unit. So what do you, just to give you bigger picture, defect per unit, what we are saying is that it's a U chart, right? U chart basically is that you have a defect divided by whatever the volume. Volume could be anything, right? Whatever the objects you have in total, that one, right? For example, simple max, let's say you have one defect or 100. That means defect rate is 1%, and in other word, yield is 99%, right? That's what we can say that. So this is the high level idea. And in the defect, whenever you're talking about bar, BAR bar, another word, for example, U bar we have, C bar we have, and then X RR chart we have, R bar we have, and then P chart we have, P bar we have, and all that. Wherever bar is there, that refers to an average, right? So whenever bar in the entire control chart, all the 7 control chart, so bar refers to an average. So let's get started. So mobile, let's say I'm gonna keep it a fixed sample, 1,000 sample. I'm going to take it out of 1,000 sample. Number of defect, or you can call it as flaws, or defect, or scrap, or the CTQs. Against the CTQ, something is missing and all that, right? For example, mobile cover is missing, or the scratch is there on the screen, or it could be any defect, right? So we are saying that defect, maybe I'll make it as a direct word called defect. So remember that defective is different and defect is different. One defective can have multiple defects. So let's go ahead and then I'm going to give it random between, let's say the defect range is between 1 to 20 as an example. So now we have got this number. And the first thing what we can do is that we can find out the individual percentage, right? So how to find? Same formula, defect by 1000. For example, in this case, 14. Let me just keep this value as constant, value. Otherwise, dynamically it will be changing. So 1.4, and then dragging it. So the best percentage we have got, the minimum, in other word, the minimum defect we had 0.2, right? And the maximum defect we have at 1.9%. Okay, so this we got that, right? Flaws per unit we got it. And now we need U bar, right? Since the denominator are same, we can go ahead and take this average. For example, let's say even if you say that average like this, since our denominator are same, we can do that. But ideally, so always have a habit of keeping like this, sum of flaws or defect, sum of mobile, right? So volume. So this will give you the right percentage, and then you can drag this up. So it's gonna be same, and you can also write it here also as well, like same like this, just doing it parallelly. So number of samples, and then you have number of defects, right? And then per unit, how we are gonna do it? 260 by 250. So 1.04. Exactly both value are matching, right? The beauty about this one is that even if you shift the in a number, for example, suddenly you have taken 500 samples, right? Still you will end up getting the right percentage, right? So that's the reason. Okay. And then n will play a role because we do need n also as well as part of the formula. N we can say here 1000, right? I'll just call this value. And then we can start doing that calculations. How we can calculate is that maybe I don't need this. I can directly do it here itself, right? So what we can do it is that U bar, this is the U bar for us, right? So this U bar plus, this is, we are talking about upper control, right? Plus 3, then what I'm doing it, this 3 square root of, maybe I can put it this way, bracket 3 times square root of U bar, again U bar, divided by, and then N. N is this one. So that means UCL is going to be 2 percentage example, right? I mean, I'll keep it 2 digit. So 2.2 percentage. So what value I'm going to dynamically use it? All the value I'm going to use dynamically, right? What I will give, function F4 I will give, just select this value. And similarly, I will select these two values also. Then function F4 I will give. Enter. So now what I can do it, I can just copy paste. So the same value has been pasted. The next step is that copy paste the same thing here. The only thing is instead of plus, we are going to apply minus because as a formula suggests. So that means minimum we are getting it 0.7 percentage, and U bar is 1.1 percentage. Maximum we are getting 2 percentage. How we can do? So just select all these one, go to insert, and then recommended chart. In the recommended chart, this is suggesting this chart. You can directly take this up. Okay, now I will just give a title called U chart for mobile defects. Okay, now this is done. And now a couple of things I need to do. So I don't need to pay. Okay, first let's find out this value. And we got that 1.4 and all that is all rolling one. All are well within the limit, right? So there is no outlier, is it? And there are only common cars exist. No special cars exist in this chart, right? This process seems to be controlled, right? So what you can do, the last one, you can click on this and add only label for this, and then right click again, you can do a formatting, you can bring it up, right? For example, right? Similarly, you can just click the last one and then, because otherwise it will look very clumsy. So then I will just keep it on top, above, right? So what I will do, I will just make this number bold, slightly up. Maybe I will make it this. So this is again, similarly, I will do it for this also. For U bar, I will make this as, okay. So I will keep it on the right side. It is there. I'll keep it on the row. Just keep it this. Okay. And this also I will do that slide formatting. Okay. And then this one to formatting, I'll keep it here. Right. So now the beautiful U chart is using this one has been calculated. Now you can see this is what we have got for this one, right? Furthermore, I wanted to keep that, I wanted to reverse this one because the lesser the defect is good, right? So I will keep it like this color. I will change it now. What I will do, I will just go to format and then shape outline. I'll give light green example. And maybe the center line, I will keep it blue color. And then the upper one, we should not have more and more rejection. So that means I'll give red example, right? But you can customize to your color palette or color format as well. So this is what it is. So it gives a grade one, whether the process is one. Let's say artificially I'll make this instead of, let's say, instead of 13 error, we have got so much error. For example, let's say we got 130 error. This is really, really, really high, right? So you see that this is going up, right? And maybe I'll undo it. Maybe I'll just show you how the outlier looks like, right? For example, instead of 13, I'll just make this number. Let's say we had double that one, right? Double the issues, 26. So again, this is an outlier, right? So we can easily find out whether the outlier is there or not there, and all that we can easily find out. Let's see whether the same thing Minitab is giving the same result or not, right? Let's do that. So copy this data because Minitab will calculate all these automatically. So go here and I'm just going to keep these values here, right? What I'm going to do is that go to stat and then directly go to control chart and then attribute chart and then U chart. Have a click on this. So mobile of defect divided by mobile. Okay. Now you see that let's notice that the same value we are getting in or not, right? So that's the question. What I'll do, I will just add that line also as well. Okay, let's compare. So here we are getting that 1.1 percentage. Here also exactly 0.1, 1.09. Let's see that 1.09, exactly the same thing. And then 2.08, 2.08, exactly the same. And then, for example, any value if you take it, like 2.6 is outlier, right? So here also 2.6, let's see what Minitab gives. 2.6 percentage, right? 2.6 percentage an outlier. Exactly, it gives everything. And then let's say I'm changing it back to this one. Let's say I'm just keeping it here. Now it doesn't show any outlier. Let's see what Minitab is giving the result. So what I'm going to do, I'm going to make it this 26 to 13 and come back to graph and then right click on this, update the graph automatically. Now the scale slightly has got changed, 0.7 and 1 percentage and 2 percentage, exactly the same thing. And here it shows that there is no outlay. Here also it shows no outlay, right? So far it is great. I mean, the tricky part comes into play is that when you change your denominator, right? The control limits also get changed, right? How Minitab does is that Minitab calculates accurately using the subgroup size, but in the Excel it is difficult to do. For example, let's say you're taking the samples. Let's say this sample, suddenly you went for 500 sample example, and then like this it is the example, right? So the same thing I will just copy paste. Now we've got some values, right? For example, let's say I think I mean U bar will get the same, but let's see whether we are getting the same value for other values. So what I'm doing it, I'm just pasting this value here and going back to this one and see. So now this has been updated 2.38, but it is also same. But actually if you have in this case, how many tab works is that, so in this among these two number 500 and 1000 is a bigger value. So the real test happens when you have a so much variations. For example, let's say I'm just giving it, my sample is between 500 to 1000. Now it will not be as accurate as Minitab. Minitab will give you most accurate value. For example, let's say now it's giving 2.88, right? So first thing what I will do, I will convert back to values as it dynamically will change otherwise. So I'm just copying this one and going back to this, pasting it here and going back to the chart, and then you see the 2.6, but here 2.88. Why? Because here we are talking about it, we have taken that first value, right? Even if you take example, even if you take maximum value, okay, even if you take maximum value, so you're going to get 2.51, but actually 2.65. Although there is a very subtle difference, but there are two outlier rate is showing up and all that. But only thing is that still it is not right, right? So maximum concept also we might not work out sometime. When you have, remember, when you have very only one kind of thing, for example, let's say just keeping it again, going back to the original example, 1000, and then you keep shifting it like 500 and all that, right? So I think it probably might get the same value, right? So for example, you're getting it 2.54, right? And I'm going back to this Excel, copy this data, go back and paste it here as well, and go back to chart and see the result 2.69, 2 point no, the value is wrong. That's what it is a bit tricky. So keeping it all the way down. Okay, I'm pasting it all. I realized that I have not pasted well. I'm just keep flipping between 1000 and this one. Let's say whether Minitab and Excel are same, right? So just pasting it here, going back to this one, 2.47. 2.47, I think it is same. Why? Because it doesn't have the too much sample variation. If you have too much sample variation, then you have to do it carefully in Excel, because Excel might tend to give a wrong value. So that is one point you need to know. Another aspect is that sometimes you might get zero, for example, minus value also as well in the LCL, right? For example, let's say you're getting that LCL, theoretically you're getting that 1%, right? As the LCL, but technically we don't say 0% error, right? So that we need to assume as, minus 1% we need to assume as 0%, right? So That is also one other important point I wanted to share. I hope you find this Excel versus many tab comparison with the real time demonstration easy. Please start using the control chart and it makes lots of difference. Thank you so much. Take care.